Hey, what's up, guys? Mr. Ernst here, e-learning day one. It's actually Friday afternoon. We just found out about this jazz, and so Mr. Moore, Ms. Fulling, and I kind of talked about what we want to do. We're going to kind of try to keep on track with what we have been doing and use our pre-formatted notes here and get you guys rolling. And so we'll explain a little bit more in a different video, but here is Monday's lesson, bearings day one. Planes and ships and any type of travel, because we're sitting on the sphere of the earth, we use bearings. And so in navigation, a bearing is the horizontal angle between the direction of an object and another object, or between it and that of true north. And so we'll explain what that means in just a second. There's actually a couple different ways that we use bearings. Like, for example, it could be 30 degrees north of east, or it could be just a straight bearing, which we'll explain in a second. When a single angle is given, it's understood that the bearing is measured in a clockwise direction from due north. So the bearing from A, which is this right here, to C, which is that guy, is 30 degrees. What that means is this being due north, we're rotating clockwise by 30 degrees. So these are just vectors which give a direction that we would be traveling. And so if you just give a single angle, it is assumed that it's in a clockwise direction from due north. Your second option is you begin with a north or a south line, and you use an acute angle to show the direction. So for example, a bearing from A to C, here's A, here's C, obviously, is S52 east, okay? So this first one is the one that you are referring to, okay? And this is the second one, the direction that you're moving in. So 52 degrees east of south. You're gonna start in the south direction right here, and we're moving 52 degrees to the east of it, okay? So it is obviously important that you guys know north, south, east, and west. If we don't know those, we're in a touch of trouble with this lesson. No, you all know those fine. So, okay, so give a diagram that represents each bearing. The first one's a bearing of 34 degrees, okay? Typically what we want you to do is just draw a full axis here with this representing north, and then give a vector that represents your direction, okay? So you're gonna always start at the origin. A bearing of 34 degrees means we're going like towards the northeast direction, and then just give a little angle showing which direction you moved and how much, 34 degrees. Second one, a bearing of 304 degrees. This is very similar to what we've been doing with angles. It's just that normally we've been treating this as 0 degrees, 90, 180, 270, 360. That's what you've been used to all chapter. Now we're starting at north, so that's 0. So this would be 0 degrees, 90 degrees, 180 degrees, 270 degrees, which means that our bearing is going to be in the northwest direction. And we know that if that's 270, that this would be 34 degrees, okay? C, north 42 degrees east. Remember that that is where you start, the direction you start, and you rotate by this amount in that direction. So here's east, here's north, north 42 degrees east, 42 degrees east, okay? D, south, obviously is down here, 31 degrees east. So here's east again. We're rotating in that direction. And this is the vector describing where you are going. Okay, that arrow. And finally, north, 52 degrees west. So we're going north, we're rotating by 52 degrees to the west. And so this is going to be describing our direction. We'll label that guy at 52 degrees. Okay, so I think that this is probably something that isn't super difficult for you. Just remember, refer to the first one, rotate in the direction of the second one by the amount that they give you. Okay, all right, so here's what we're going to use them for now. They're just going to give us some situations, and ultimately what's going to end up happening is you're going to set up a triangle like we've been working with. Usually it's going to be a non-right triangle, and so we're going to have to use law of sines or law of cosines, but let's just get rocking. Radar stations A and B are on an east-west line. Okay, so here's an east-west line, and they're 3.7 kilometers apart. So I'm going to go ahead and label that 3.7 kilometers. Station A detects a plane at another point C on a bearing of 61 degrees. Now, notice I haven't labeled A and B yet because I don't know which one is to the west and which one's to the east. So Station A detects a plane at another point. I'm going to make another quick drawing here. If this is Station A, C. Okay, he sees a plane at point C at a bearing of 61 degrees. So since they only give us one direction there, we know that we're referring to north and we're rotating in the clockwise direction. So I'm going to make a small sketch here, 61 degrees. We know that relatively speaking, that's how A and C have to lie. So my guess is going to be that A is going to be right here. But let's check it real quick. Station B simultaneously, meaning at the same time, detects the same plane at a bearing of 331 degrees. Okay, so now this is Station B. He sees C at a bearing of 331 degrees. So here is 0, 90, 180, 270. Aha. C is going to be up here because that's 270. He sees him at 331, so we need 61 more degrees. I can safely say this is A, this is B, and now I'm just going to put those two drawings together. Okay, I know that C sits right up there, okay, with this angle, okay, being 61 degrees, okay, and this angle right here, I'm stealing that, being 61 degrees. Okay, now we have to use a little bit of complements here because if this is 61, what's left over? Well, I know that each north and east intersection is going to make a 90-degree angle, so that leaves me with 29 degrees right there. And now I have a triangle. Let's figure out what I want to answer here. Find the distance from A to C. So I want to know X. I want to know what that is. I can use law of sines, it looks like. I just need to figure out what this angle is. So I've got 29 plus 61. That gives me, 90 degrees. This is a right angle. I can do this simply as well. I can, since I have a right triangle, I could use SOHCAHTOA. I can also just use law of sines. It will work if it's 90 degrees. So I'm going to show you how to do it with just law of sines to start. I know these two, so I'm going to set up my proportion. Sine of 90 over 3.7 is equal to, I want to use this pair here, sine of 61 degrees over x. okay? I'm gonna cross multiply those guys, and I'm gonna get 3.7 sine of 61 degrees equals x times sine of 90. When I crunch all of that out and I solve that, you guys have been doing that for a while, I'm not going to go through all that. I get my distance, which is x, being equal to 3.24. So I'm going to label that here, 3.24, and we are in kilometers. So x is equal to 3.24 kilometers, okay? So it's not that much different than what we've been doing. I think the big key is that you start with a north, south, east, west line and figure out which direction you're working in, okay? Last one for the day here. The bearing from A to C is 52 degrees east. I'm going to make a mini little sketch here again. I'm going to label this guy A. C south, 52 degrees east. So I put that A not where I wanted it. Okay, south, and then 52 degrees to the east. So here is my first bearing. To get from A to C, I'm going south, 52 degrees east. The bearing from A to B is going to be north, 84 degrees east. So that is almost due east, because we're rotating 84 of the 90 degrees in that sector there, okay? And so what does that mean? These 2 points are going to be the same. We got to figure out where the points are. Well, these are on top of each other, so I can safely start right here and label this point as A. I'm just combining these two pictures. I know that if I go down in this direction, what point do I see? No pun intended. I see point C, okay, this angle, 52 degrees. I'm going to put that back on top here because that's point A again. I know if I rotate in that direction, I see point B. So that is B. This is 84 degrees because that's what they told us up there. We know then that what is left over, this small little angle, 6 degrees, okay? What's left here? Well, 90 minus 52 is 38 degrees, okay? So we're going to find this whole angle in a second. Now, the bearings we have set down here, the bearing from B to C is 38 degrees. Or south, 38 degrees west. So that's good. That makes sense in our picture here. That one is 38 degrees. Okay, we're rotating back in that direction. And so here's what we look like. Now it says a plane flying 250 miles per hour takes 2.4 hours to go from A to B. Find the distance from A to C. So first things first, I'm going to take that and I'm going to make it slightly less confusing by just taking 250 miles per hour and I'm going to multiply it by the 2.4 hours to figure out how far we went. That is going to end up giving me 600 miles. So the distance from A to B is going to be 600. And I'm trying to find the distance from A to C, okay? So what I need to do is just clean up some angles here. This is where we're going to introduce or reintroduce or talk about I know that all east-west lines are parallel. So that means that this tiny little angle here and this tiny little angle here are alternating interior angles. So that means that this one has to be 6 degrees. Okay, so we've got 38 degrees, we've got 6 degrees, we've used 44 total degrees. That means there are 46 left over. And how do I know that? Because I know there are 90 total degrees in here. Okay, I use 6, I use 38. There are 46 degrees left. And now I do believe, oh, no, I lied. I got to find this angle yet. This one, 38 and 6 together make 44 degrees. Okay, so I now have a 44 degree angle, a 46 degree angle. That leaves this with 90. Okay, and so this time, last time we solved it using law of sines. I told you it would work. This time I have another right triangle. I'm gonna use it or solve it not using law of sines this time. I'm gonna redraw it. I've got 600, I got 90, I've got 44 degrees, that's A. I've got 46 degrees down here, that's B, okay. And I need to find the distance from A to C, so I wanna find this guy. I'm just gonna use old SOHCAHTOA. So I have opposite, hypotenuse, I'm going to say sine of 46 degrees is equal to x opposite over 600. And when I crunch that out, I get 431.6 miles. Okay, multiply both sides by 600. Okay, so I think long story short, the few takeaways from this. Number one is that every single time you see a quadrant from north to east, you have 90 total degrees from there, and you're going to need to be able to add and subtract to be able to find those. And the second part is that alternating interior angles are going to play a big part in this. Okay, when you draw a line from one north-south to another, north, south, east, west, and you have alternating interior angles, you can assume that east-west lines are parallel and you're able to drag those over, okay? We will get you going with more bearings as the week goes on, but hope you guys had a nice weekend. Bearings day one, ladies and gents.